Practice quiz on radiometric dating. Base your answers to questions 1 and 2 on the graph below and on your knowledge of Earth science. The graph shows the number of radioactive isotopes X atoms present as a sample of the isotope undergoes radioactive decay. Number 1. Based on the graph, what is the approximate number of radioactive atoms of isotope X that are present when 8 hours of decay has occurred? At 8 hours of decay, the number of atoms would be greater than 150. Best estimate, letter C. Based on the graph, the half-life of this radioactive isotope is, starting off at 1,000 and getting to 50% of 1,000, which would be 500, or half of 1,000. The half-life time would be 3 hours. Scientists infer that early North American humans hunted the mastodon. Carbon-14 dating of the rib bone indicates that 2.4 half-lives have passed since the mastodon was killed. Approximately how many years ago did the mastodon die? 2 half-lives would be 11,400 years. 3 half-lives would be 5,700 years. Answer C fits in between those two ranges. If I do take 2.4 times 5,700, 5,700 years times 2.4 does yield the answer 13,680 years. Base your answers to question 4 through 7 on the graph below and on your knowledge of Earth science. The graph shows the percentages of radioactive isotope carbon-14 and its disintegration product produced during 4 half-lives of radioactive decay. The age of which index fossil could be determined by using carbon-14. Since carbon-14 has a relatively short half-life, it can only be used for samples up to 50,000 years ago. In the index fossils referenced here, here's the trilobite. Brings me back to the Cambrian period, 488 million years ago plus. Brings me to the Jurassic period, which is 200 million years ago plus. Which matches up with the Pleistocene period, which is a possibility. That's only 10,000 years ago. Matches up with the Devonian period, which is 359 million years ago. Number 5, how many half-lives have passed if a sample contains 25% of its original carbon-14? Here's the carbon-14 chart moving down here. It reaches 25% at this point. Moving down to the bottom of the chart, I see it says 2 half-lives. Number 6, which disintegration product is represented on the graph? At the top, it says the graph shows the percentages of radioactive carbon-14 and its disintegration product produced during 4 half-lives. Carbon-14 disintegrates into nitrogen-14. Number 7, radioactive carbon is often useful in determining the absolute age of geological samples because radioactive isotopes decay at a regular rate that's not affected by any external conditions such as temperature, pressure, or chemical combinations. Number 8, a fossil formed 11,400 years ago. Which percentage of the original amount of carbon-14 remains in the fossil? 1,400 divided by 5,700 equals 2 half-lives. During the process of 2 half-lives, 100% would split to 50%, and 50% would split to 25%. Number 9, the graph below shows the radioactive decay of rubidium-87. What percentage of rubidium-87 atoms will be left after 4 half-lives? After 1 half-life, 50%. After 2 half-lives, 25%. After 3 half-lives, 12.5%. After 4 half-lives, 6.25%. The radioactive decay of K40 atoms in an igneous rock has resulted in a ratio of 25% potassium-40 atoms to 75% argon-40, calcium-40 atoms. How many years old is this rock? Potassium-40 has a half-life of 1.3 times to the 9th years. At 0 half-life, 0 years have passed, and we have 100% potassium-40, and argon and calcium 0%. After 1 half-life, 1.3 times 10 to the 9th years has passed. Calcium's dropped out. Potassium's dropped down to 50. Decay products gone up to 50%. After 2 half-lives, another 1.3 times 10 to the 9th years has passed. We're up to 2.6 times 10 to the 9th years. The amount of potassium-40 is now 25%. The amount of argon and calcium is 75%. We've passed 2 half-lives. 2.6 times 10 to the 9th years have passed. Number 11. Due to radioactive decay, an igneous rock sample now contains 1/4 of the amount of the potassium-40 it originally contained. The age in years of this rock sample is approximately. This question is just a repeat of the previous question. You can see that when we got down to 25%, which is 1/4 the original, the number of years that had passed was 2.6 times 10 to the 9th years. Number 12. How much of an 800-gram sample of potassium-40 will remain after 3.9 times 10 to the 9th years of radioactive decay? Potassium-40's half-life is 1.3 times 10 to the 9th years. 3.9 times 10 to the 9th years divided by 1.3 times 10 to the 9th years yields 3 half-lives. If you had 800 grams, after 1 half-life you'd have 400 grams. After 2 half-lives you'd have 200 grams, and after 3 half-lives you'd have 100 grams. Number 13. The graph below shows the decay of a radioactive material over time. How long does it take for this radioactive material to decay through 2 half-lives? After 1 half-life, 50% would remain. After 2 half-lives, 25% would remain. At 25%, we're up to 10 times 10 to the 3rd years. Answer, letter C, 10 times 10 to the 3rd years.